For the final course project for the Bike Share program, I will describe kind of the steps that I went through over the last 7 weeks, going on to 8 weeks, in order to create that plan and describe how it would be actualized. So first I created a plan for inputs and outputs of the customer, the bike station software, the network and database software, storage systems required, and any third-party integrations, as well as support for analytics and logging and reporting. As I did this, it identified each step of the process, from the customer initiating a request for information about the bike share program to choosing a subscription type, inputting personal info, or identifying themselves via a third-party login instead, to how they would pay, and then finally remove the bike from the station. This really helped break it down and visualize each input and output of both human elements associated with the bike share program, as well as the system elements that were needed or back-end processes. After that, I researched hardware and software architecture that would support those inputs and outputs. So this included front-end kiosk, monitor, touchscreen, software, credit card payment, networking, router that was needed, how it would transfer that data through cloud services into most likely Amazon Web Services was my recommendation, and how it would then interface on the network side with any third-party integrations required. This is when I really began to believe that analytics and reporting database that had been determined in the initial inputs and outputs would be better separated from the core databases so that it could be accessed without having any sort of impact on the core databases processes of information coming in from users. Then we researched the security needs. So in doing so, it was both the encryption for data transmission and storage, as well as access control lists to ensure that remote access to these web services, or even to a kiosk machine, if that allowed remote access, was only to authorized individuals, as well as having rate throttling to thwart any sort of denial of service attacks. On the hardware side, however, because we had a credit card reader inside of the BikeShare system, having a skimmer or a credit card skimmer device prevention would be installed, as well as securing GPS information from the bikes themselves so that only those people who had access to it could find out where the bike was in order to retrieve it should it not be returned by the person who had checked it out. After those items were done, I created a more complex development flowchart, like a decision tree, for writing various data elements to the database regarding the user, the bike usage, and billing requirements associated with each step of that process. Thereafter, a data dictionary was created to specify the databases for which the objects and fields would need to be stored and the associated method for each of those fields. So whether it was going to be an array, an integer, etc., per data element, and the comments regarding how the field would actually be used so that the system could be built by the development team, having kind of a roadmap ahead of time. So when they went and built the SQL tables, they could select these different options within those field level attributes in order to create the data of the right types, and also kind of visualize how that was going to be used when it was actually coded for use. The visual database design was then modeled for primary keys and foreign keys. So this is how all of the different database tables would talk to each other and transmit information between each other, as well as additional attributes that should be contained within each of the entities or the tables, and the queries to retrieve the associated data elements needed so that ride time could be retrieved, average ride duration could be retrieved, number of bikes checked out from any given bike station. I had to kind of decide what was a given bike station, since a user may not return it to the same bike station they checked it out from. So decided that was going to be the last checked in bike station would be the bike station that it was checked out from, and a current list of active users. So this not only helps by doing this visual database design process with the SQL table creation, but also assists in both technical and non-technical stakeholders reviewing the same documentation, even collaboratively, to ensure that the accuracy is on both sides. They understand how this data is going to be transferred back and forth, and the stakeholders can ensure that the data that's being collected and how it's being used is what they actually need to do or what they need to get, so that when the developers build it, there will be less refactoring, always some refactoring, but less refactoring associated with misunderstandings of that data itself. Then summarizing that into the overview for the outcome of the system proposed, the way the system would be organized, and the security needs of the system, or as I did that, there were 8 major tasks identified for both the business requirements side as well as the development side of the BikeShare system. And that included ensuring quality assurance testing, user acceptance testing, and security testing would take place iteratively within the tasks identified. So the first was to establish contracts with third-party payment processors, personal info import providers, as well as Amazon for the Amazon Web Server hosting environments. And then as part of each of those, you would also have to establish API access on the development side. So the contract side would be more for the business to take on, whereas the APIs and associating those with the systems would be, or getting those so that they can be associated with the systems would be more on the development side. All those connections should be tested to ensure that the API keys worked correctly before actually putting that into development. Then the business needs to decide if they want to buy or build the physical bike docking station, as well as equip the bikes with GPS tracking, the encrypted GPS tracking. And they should test that physical build and the GPS tracking to ensure that the data is being transmitted correctly. Then they should decide if they want to buy or build the kiosks that are going to be attached to the bike docking station. And those would be equipped with limited computing hardware, software, touchscreen monitor and display, and then the secured credit card payment device, as well as the internet router and the connection for the data transmission. And they would also need to test the physical build and security of that at that time. Then once the developers kind of got to take over and build and deploy the front-end software to that kiosk, likely this could be maybe not installed, but maybe a web-based configuration to support the physical with only a limited set of code on the kiosk itself to support any sort of touchscreen physical kiosk interaction. So they would be able to do that on the front end and then QA that to ensure that the software was working as expected, even if it couldn't connect to the back end yet. Bug fixes needed, and then complete a final user acceptance test of the on-kiosk interactions with clients. So ensuring that when clients tapped on different things, different elements within the kiosk, they were getting what they needed out of that. If that wasn't the case and we needed to go back and change something, that would really be the time to do it before all of the connections to the backend databases have been created. We may have to change something in the backend database to support a front-end change, for example, if users really needed something different than what we had initially thought that they wanted or should be able to use. Finally, after that had been completed, would be to create the Amazon Web Services virtual server environment for the backend network software itself, and then create 3 SQL database servers for each identified relational database, and then complete the load and network speed testing between the front end and back end. Really, you could do that before you build out all of the database itself to make sure that there isn't any issues just even hitting the server from the front end kiosk. Afterwards, using that logical data model, the data dictionary, the visual database design previously discussed, then each of these relational databases could be built, including the interactions with the third-party integrations and the analytics database that we discussed earlier. After that was done, building the backend network software on the virtual server itself and configured to interact with the third-party data stores via API would be performed as well, so that the virtual SQL servers, say over there on AWS, then had the full database implementation that had been modeled previously in the logical data model and diagram. And then really completing that end-to-end testing as well as load testing of the actual data that's being transferred across the kiosk cloud to the AWS systems, the third-party integrations, the analytics database, to ensure that there aren't any breaking points within that. After that's done, then really that QA, the quality assurance of the front end, the back end, making sure the stakeholders are getting what they need out of the data when stuff is put into the front end, making sure all of that's operationalized and working as expected. And then really taking it to users again and saying, use this thing, let's see how this works, and going through and making sure that there aren't any final design changes that need to be completed. And then I would tack on the security testing in order to ensure that we weren't locking down the system so much because of security testing that the users couldn't actually complete their tasks at hand. But once the security testing would be completed, then ensuring that all of the systems and services that the user had been using during UAT were still up and running and functional. That would be my course project description, and I look forward to hearing your thoughts. Thank you for spending this 8 weeks listening to my terrible YouTube videos.